Good morning children. How are you? I hope you are well and safe. In last class, we learned about heat. Today, we are discussed another important chapter for 10th class is structure of atom. Structure of atom. In your last classes, in 9th, in 8th classes, you are familiar with atoms and some models of atomic structure, that is J.J. Thomson model, Niels Bohr model, Rutherford model. You are learned in lower classes. Let us recall those important points of the structure of atom. First of all, what is meant by atom? Atom is a smallest particle. It is a bully particle. Atom is a smallest particle and it is a bully particle. Atom consists of protons, neutrons, and electrons. Protons is magnitude plus 1. Proton has magnitude plus 1. Electron consists of magnitude minus 1. Electron consists of magnitude minus 1. Protons and electron has same magnitude. Protons and electrons has same magnitude. Here, protons are designated by P positive. Electrons are designated with E minus. Electrons are designated with E minus. Neutrons are neutrally charged, is designated with like this. Electrons is E minus, protons P plus, electrons neutral. That means denoted like this. Here, protons and electrons both are electrically equal. Protons and neutrons are electrically equal. Here we note down one more point, that is mass of protons, electrons and neutrons. Mass of mass of protons is 1.0078 AMU. Like that, mass of neutron 1.0087 AMU. Like that, electron mass, when compared to proton and neutron, electron mass is very negligible. It is lesser than proton and neutron, 2000 times lesser than the mass of proton and neutron. Mass of electron is 0.00005 AMU. Here, roughly, mass of proton and neutron is around 1. Here, electron mass is 0.5. It is very negligible when compared to protons and neutrons. Here is one small point is there. Electron is negatively charged particles. Protons are positively charged particles. But neutron has with charge of neutral. Neutron has neutral charged, but neutrons have mass is higher than that of electrons and protons. You will observe 1.00087 AMU mass of the neutron. Mass of the proton is 0.0078 AMU. The mass of neutron is heavier than the protons and electrons. Next, protons is positively charged. Neutrons are neutrally charged. They both are combined to form nucleus. Both are combined and form nucleus. Both are combined and to form nucleus. Nucleus is the center of the atom. Nucleus is in the center of the atom. Nucleus is denoted with capital N. Nucleus is denoted with capital N. It considers the charge is positively charged because of proton has positively charged, negative has neutrons has neutral in charge. So nucleus attains positively charged. Okay, electrons are revolving around the nucleus. Electrons are revolving around the nucleus. Here, the mass of an atom is depends upon the center of the center because of the protons and neutrons are containing in the nucleus. That why the mass of atom is mainly depends on the center of the atom because of electrons mass is negligible. Electrons mass is negligible when compared to proton and neutron. The mass of proton and neutron is 2000 times heavier than the electron. Okay, children. Protons and neutrons are called as nucleons. Because of they are present in nucleus. That why we are called as nucleons. Protons and neutrons are called as nucleons. Okay. Today we are discussing another topic, that is spectrum. Children, are you familiar with rainbow? Are you familiar with rainbow? What are colors in rainbow you observed? There are 7 colors in rainbow. There are 7 colors in rainbow. What are they? Violet, indigo, blue, green, yellow, orange, red. These are the colors you are observed in the rainbow. This is called as spectrum. This is called as spectrum. This is called as spectrum. Vibgyor, how it forms this violet, indigo, blue, green, yellow, orange, red. Why these colors are appeared? How it is formed? These are interesting topics or you learn in human and colorful world. Okay, today we are learn about next topic, characteristic of light. To know how atoms are arranged in same element like this, this type of topics are you must learn about first the nature of light and the colors emission of light is important. Today we are discussed such topics. First, characteristic of light. Character of light. Character of light. Okay. Take one stone, threw into the still water. What do you observe? The water is disturbed. The water is disturbed and form wave and form like a wave like this. Form wave like this throughout the medium. Form the wave like this throughout the medium. Okay. This is the wave propagation. This is the wave propagation. The continuous change of charged particle can change the electric field. Here is this is the important point. The change of or the vibration of charged particle can produce the electric field. The continuous of vibration of electric field can changes the magnetic field also. So okay. Today we are discussing this water experiment. Take one bucket of water. Take one stone and throw it in water. What do you observe? The water is disturbed. The water is disturbed like it forms waves like this. The water is disturbed. It can form sound waves also. Sound wave. Here, water wave. formed crust, trough, crust, trough, crust and trough. Here, highest peak of the point is known as crust. The lowest part is trough. Peak of the point crust, lowest part trough. Crust and troughs are formed. This is the medium of propagation. The wave transformation, the medium of propagation. Here, sound waves are produced like this. In this water wave, molecules are travelled through the perpendicular to the medium, like this, perpendicular to the medium. Wave is like this. The particles are moved on the wave to perpendicular of this wave. This is called as transverse wave. This is called as transverse wave. In this wave, observe some molecules are closer, some molecules are distant. Some are close, some are far. Some are close, some are far. Here we are formed. Here we observed compression and rarefaction. Compression, rarefaction. Compression, rarefaction. Here in this type of waves, in this wave, we find the movement of the waves is like here perpendicular, it is called as transfer wave. Here like this, these are called as longitudinal waves. Here longitudinal waves. Here wave are transferred perpendicular to the wave. Here wave is transferred or motion of your particles is in the perpendicular to the wave. Here wave is transferred like this along with the wave. Here it is formed longitudinal waves. Both transverse wave and longitudinal waves are to propagate the wave. Both transverse and longitudinal waves both are to transverse the wave. The medium is compulsory. When medium is present, they are transformed one to another place. Okay, continuous vibration of a particle is formed electric field. Electric field are formed perpendicular to the wave propagation. Electric field is formed perpendicular to the wave propagation like this. Like this. The continuous vibration of electric field can change the magnetic field also. So, magnetic field are formed like this. Magnetic field formed perpendicular to the electrical field. Perpendicular to electric field. Like this. This is known as electromagnetic wave. This is known as electromagnetic wave. This is known as electromagnetic wave. For electromagnetic wave, we cannot want to travel the electromagnetic wave. No medium is necessary. So, electromagnetic wave can travels in vacuum and also medium also. Electromagnetic wave can travel in vacuum, whether in medium also. Here it is a wave propagation, it is electric field, it is magnetic field. Electric field, assume that it is a electric field, it is a electric field, it is a magnetic field. Electric field and magnetic field are both are always perpendicular to each other. Both are always perpendicular to each other. It is a electric field. Its direction is upward direction. The magnetic field is direction to like this. Both are compared. Both are longitudinal to or perpendicular to each other. Magnetic field and electric field are perpendicular. Take like this. Magnetic field and electric field. Both are perpendicular. Take like this. Both are perpendicular. Whatever it is, magnetic field and electric field are perpendicular to each other. Here you take electric field, magnetic field. It is denoted electric field. This is denoted magnetic field. Its direction is towards you. Magnetic field direction is towards you. This is wave propagation. Magnetic field and electric field both are perpendicular to the wave propagation. Observe this. This is electric field. This is magnetic field. This is wave propagation. Magnetic field and wave propagation is perpendicular to each other. Electric field and wave propagation is also perpendicular to each other. So, this can travel like this. Wave propagation is like this. Electric field is this. Magnetic field is this. This is the wave propagation. This is the wave propagation. Like this, wave is propagation. Magnetic field is towards you and electric field towards up. For magnetic field, there is no necessary of medium. It can travel whether vacuum or medium. Here we can discuss another important point. The electromagnetic wave depends upon three factors. The electromagnetic wave depend each other. Three factors. They are wavelength, frequency and speed. Okay, longitudinal wave and transverse wave are both are want to travel medium but not electromagnetic wave. The characteristic of electromagnetic wave. The character of electromagnetic wave is depend upon three factors. That is, they are wavelength. That is wavelength and frequency. That is frequency and speed. These are the characteristics of electromagnetic wave. Another important point. The speed of electromagnetic wave is 3 into 10 to the power of 8 meter per second. That is, C is equal to 3 into 10 to the power of 8 meter per second. This is the value of electromagnetic wave speed. Electromagnetic wave characteristics is depends upon three factors. That is wavelength, frequency and speed. First of all, what is meant by wavelength? Wavelength means, first of all, we defined wavelength. Wavelength is the distance between the two adjacent points, that is test to or throw to throw. The distance between two nearer test to test distance or throw to toe distance is known as wavelength. Wavelength is denoted as lambda. Wavelength means the distance between the two nearer or adjacent trace to trace distance or throw to throw distance is known as wavelength. Frequency means the number of vibrations takes place in particular time is known as frequency. Speed. Its traveling capacity is also known as speed. Later, you will discuss it some more important points. Okay, the characteristic of electromagnetic wave depends upon three factors. That is wavelength, frequency, and speed. First of all, we learn about what is meant by wavelength. Wavelength is the distance between the two nearer adjacent crest to crest or throw to throw. Here, observe, this is a wave. The distance between the two crests, the distance between two crests or the distance between two throws is known as wavelength. The distance between the two nearer crests or the distance between two nearer throws is known as wavelength. Wavelength is denoted by lambda. Wavelength is denoted by lambda. Next, we learn about frequency. Frequency means the vibrations takes place in the particular period of time is known as frequency. Frequency is denoted by mu. Frequency is denoted by mu. For wavelength, CGS unit is centimeter. In SI unit, is centimeter. CGS units are meters. Here, frequency is denoted as mu. Frequency is denoted as mu. Frequency means the number of vibrations takes place in particular time is known as frequency. Frequency is denoted as mu. Speed. What is meant by speed? The speed of a object which is travelled in a particular time is known as speed. Speed is an object travelled in a particular time is known as a speed. These are all characteristics of electromagnetic wave. Here, one observation is that here lambda is denoted by wavelength. Wavelength is denoted by lambda. Lambda is inversely proportional to 1 by mu. That means wavelength is inversely proportional to frequency. That means wavelength is high, frequency is low. Frequency is low, wavelength is high. Here, example for this, red color has higher wavelength but lower frequency. Violet color has low wavelength, higher frequency. That means lambda is inversely proportional to 1 by mu. That is, wavelength is inversely proportional to frequency. Later, we will discuss another topic. Electromagnetic spectrum is a group of different wavelength electromagnetic wave. Electromagnetic spectrum means the group of different wavelength electromagnetic waves is known as electromagnetic spectrum. Electromagnetic spectrum contains radio waves. Electromagnetic spectrum contains radio waves, microwaves, and infrared rays, IR rays, and visible rays, and ultraviolet rays. That means UV rays, and X-rays, and gamma rays, and cosmic rays. Electromagnetic spectrum means the different wavelengths of electromagnetic wave contains is known as electromagnetic spectrum. Here observed one wave. Here we observed one wave. Here first radio waves. Radio waves. Assume the wave. That's assume a wave. Low wavelength gradually becomes higher wavelength. Okay, first radio waves, then microwaves, IR rays, visible rays, UV rays, X-rays, gamma rays, and cosmic rays. Here one point is observed. Electromagnetic spectrum contains these rays, radio waves and IR waves, visible rays, ultraviolet rays, X-rays, gamma rays, cosmic rays. But here is we observed a small difference. Here higher frequency has radio waves. Higher frequency has radio waves. Lower frequency has cosmic rays. Here starts with reverse. Here starts with in this wave. This is first cosmic rays. Then gamma rays and X-rays, UV rays, visible rays, IR rays. Next IR rays, microwaves and radio waves. Now you observed higher wavelength has radio waves. Higher wavelength has radio waves. Lower wavelength has cosmic rays. Here one spectrum is there. Here one spectrum is there. That spectrum is visible to our eyes. That means we are able to see that spectrum. That spectrum is visible spectrum. The visible spectrum range is up to 400 nanometers to 700 nanometers. Below, around this wavelength, we can clearly observe by our eyes. This is called visible spectrum. Beyond the 700, we are unable to see the spectrum, and also below the 400, we are unable to watch the spectrum with our eyes. Our visible spectrum is in between 400 to 700. We are seeing colors which are all colors are between in these values 400 to 700. We observe the colors are between 400 to 700. Okay children, are you able to follow me? Next, another one interesting topic on this. First, take one rod. Iron rod, wherever it is. Put fire for this rod. Iron rod, generally it is appears in black in color. What do you observe? Gradually we put fire for a rod. What do you observe? Gradually rod becomes red color. Then it gradually turns to which color? Gradually turns to orange color. Turns to orange. Then we are still heating. The rod will changes to which color? Yellow color. Turns to yellow color. Like that. We are putting heat. The color is changed. Red, orange, yellow. Like this. Green, blue. Finally, they attains white color. White color contains these which are colors are all which are colors. First, we heating the rod is in red color. Later, it will turns to orange, and later it will turns to yellow and green, blue, like that. Here, the energy is continuous. The color of the rod is changed. The color of the rod is changed. First, here the energy is continuously, the energy is emission is takes place in continuously. Scientists are also derive the energy is the form of energy. It can emission of continuously like this. Observe this, children. It is the flow of water. Flow of water. Flow of water is gradually. Flow of water is continuously. Flow of water is continuously. With a small amount also, it will continuous gradually. Energy is also like this. It is a gradually, continuously energy is emitted. Okay. Then our Max Planck is a scientist. He described it. Energy is not continuous emission process. It is in energy emitted in packets in the form of packets like this. I will take some grains. I will take some grains. Not it is continuously. Its emission is after some time granules are dropped. After some time, one granules are dropped. Here, continuous emission is a tap. Water flow. Continuous emission. Here, drop is example for not continuous emission. Here, Max Planck is give one derivation for us, that is for energy. E is equal to H mu. E is equal to H mu. Here, E is energy. Here, E is energy. H is Planck's constant. H is Planck's constant. H is Planck's constant. Here, mu is frequency. Here, mu is frequency. Here, mu is frequency. E is energy. H is Planck's constant. Mu is frequency. Here, Planck's constant value is H is equal to 6.626 into 10 to the power of 34 joules per second. Here, Planck's constant value is H is equal to 6.626 into 10 to the power of 34 joules per second. Here, energy is emitted in the form of 1E, 2E, 3E, 4E, 5E, like that. Here is energy is not in the form of 0.5, 1.5, like that. Energy emission is in the form of 1E, 2E, 3E, 4E, 5E, 5E, like that. E means energy. Here H is Planck's constant, 6.626 into 10 to the power of 34 joules per second. Here H is a Planck's constant. It is a constant. That's why we can tell like this also. Energy is high, frequency is also high. Energy is high, frequency automatically. If energy is high, frequency also high. Energy is high, frequency is also high. Okay, children. Are you able to follow me? Write down key points of the. I will discuss it later. some interesting topic. Before that topic, you will general instruction for you. Note down the key points while I am teaching. You will write some important points. Wherever you confused, then that point is also arised to me. I will explain for you answers. Okay, next our topic is quantum numbers. Quantum numbers. Next our topic is quantum number. Next our topic is quantum number. Every electron in an atom described by a three numbers. Every electron in an atom described by a three numbers that are n, l, m. That they are n, l, m. There, that is principal quantum number, angular momentum quantum number, magnetic quantum number. Today we are discussing detailed these quantum numbers. First of all, principal quantum number. First, principal quantum number. Principal quantum number denoted by n. Principal quantum number denoted by n. It describes the size and shell of an atom. It describes the size and shell of the atom or electron. It is started with 1, 2, 3, 4. N is started with 1, 2, 3, 4 numbers. Here, number of subshell is like this: 1, 2, 3, 4. S K, L, M, N, like that. Principal quantum number is denoted by N. It describes about size and shape of the atom. Next, magnetic quantum number. Next, magnetic quantum number. Angular momentum angular momentum quantum number. It is denoted by angular quantum number denoted by L. This is denoted by L. This is explained. This angular quantum number is starting with integer 0. It is starting integer is 0. Here shells are starting with 0, 1, 2, 3 like this. Here 0, 1, 2, 3 like this. Here the number is starting to 0 integer to n minus 1 value. Here it is starting with 0 integers to n minus 1 value. Here angular quantum number is denoted the space in the atom around the nucleus is described by the angular quantum momentum. Next, our another quantum number, that is magnetic quantum number. That is magnetic quantum number. Magnetic quantum number. Magnetic quantum number. Magnetic quantum number is represented or denoted in minus value, including 0. It's represent plus 1 values. So these are the quantum numbers on your syllabus. These are the quantum numbers on your syllabus. Okay, children, for your writing of electronic configuration, electronic configuration, you have learned first Euler diagram. Euler diagram. Euler diagram. Take children 1s, 2s, note down 3s, 4s, 5s, 6s, dash dash dash. We cannot end. Second one. There is no one p orbital. There is no one p orbital. It starts with 2p orbital. 2p orbital, 3p, 4p, 5p. Okay, children. 2d orbital is not there. Start with 3d, 4d, 5d. For sake of you children, I will draw this diagram easily. Okay, the electron enter first to 1s or 1s. Then, like this, not like this, like this. Electron are entering like this. First 1s, then 2s, then 2p, then 3s, later 3p, then 4s, later 3d, 4p, 5s, then 4d, 5p, 4s. Okay, children, are you able to follow me? Electron enter first 1s, not like this, like this. Next 2s, then 2p, 3s, like this. Then 3p, 4s, then 3d, 4p, 5s, then 4d, 5p, 4s. Like this, electron enters. Like this, electron enters. Okay, children, let us learn about shape of s orbital, p and d orbitals. Here you observe 1s, 2s, 3s, 4s, like that, 2p, 3d, like that. Okay, we observe first of all s orbital, shape of the s orbital. S orbital s orbital contains maximum number of electrons attains to p orbital attains maximum electron number 6. D orbital contains 10 electrons. F orbital contains 14 electrons. S orbital contains 14 electrons. Okay, now S orbital is in spherical shape. S orbital is spherical shape. P orbital is dumbbell shape. Dumbbell in shape. D orbital is double dumbbell in shape. D orbital is double dumbbell in shape. Double dumbbell in shape. Okay, I will draw the shape of these orbitals. Let us observe, children. Board is too congested to write. The test of chalk piece is on my nose also. Okay, s orbital is in spherical shape. Okay, Nana? Are you observed? Spherical in shape. Electron is where? Here, 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 here. Wherever it is, because of electron is revolving around the nucleus in their shells. Okay. Here, electron probability is there. It is x-axis, y, z-axis. This is the shape of s orbital. This is the shape of s orbital. Okay, p orbital. Shape of the p orbital. It is x-axis, y, z. Here, p orbital is dumbbell in shape. P orbital is dumbbell in shape. Here, p orbital in x-axis. Then I will write px. Here, Here p orbital is in y-axis. Here p orbital is in x-axis, y-axis. Here also z-axis. Here p orbital is in y-axis. It is py. Here p orbital is in z-axis. We will write pz. We will write pz. Like this, d orbital also we can draw. Like that, d orbitals I can draw. D orbital. D orbital is double dumbbell in shape. D orbital is double dumbbell in shape. Okay. D xz. This D xz. Here observe. D y z. Here you can observe D x y. Here you can observe D x square. Like that, D orbital shape or like this. Here is a D orbital shape. Students, are you able to follow me? Here is a chance to asking question for the diagrams of S orbital, E orbital and D orbital without any parts in these diagrams. In these diagrams, there is a no parts. Easily you can gain the full marks in diagram section. So you can practice S, P, D orbital shapes and also practice electronic configuration. Electronic configuration is basic to write electronic configuration and in chemical bond, formation of chemical bond, the electronic configuration is basic. So you can concentrate on electronic configuration also. I can write and I can explain how to write electronic configuration. You roughly draw Euler diagram because of your easy for writing electronic configuration. First, hydrogen. Hydrogen is first element of modern periodical table. First electron is hydrogen. Second, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. First one is hydrogen. Second one is helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. I will tell up to 10. You can practice it 11 to 38 elements. It is easy for your chemical bond formation and in examination also write the configuration of nickel, write the configuration of copper. Like this questions are given for you children. So please concentrate on this topic and write down on your notes. Okay, first element is hydrogen. Hydrogen consists of only one electron. First electron enters into the first 1s orbital. That's why I will write 1s1. I will write 1s1. Here, s orbital contains able to contains 2 electrons. P is 6, D is 10, F is 14. You can remember in your mind and write the electronic configuration. First, hydrogen 1s1, helium 1s. Here, helium has 2 electrons, lithium has 3 electrons, beryllium has 4 electrons, boron 5 electrons, carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon 10. These are the electron numbers. These are the electron numbers. Okay, helium contains 2 electrons. It is a noble gas. It is a inert gas. It contains 2 electrons. Except helium, the remaining inert gases are obey the octet rule except helium. Okay, next lithium. It contains 3 electrons. Okay, we will write 1s2. 2 orbital filled. Next, go to electron into next orbit. That is 2s. That is 2s. 1. Here, remember children, the number of electrons is equal to the number of the subshells. Okay, next beryllium 1s2. 1s2, 2s2 because of 4 electrons are in beryllium. Like that 1s2, 2s2. S orbital all, S orbital filled. Next go to next orbital 1s, 2s, then 2p1. Okay. Carbon 1s2, 2s2, 2p2. Here count this number 2 plus 2 4, 4 plus 2 6. Here is number 6. Also electronic number is also 6. Then 1s2, 2s2, 2p3. Here 1s2, 2s2, 2p4. 1s2, 2s2, 2p5. 1s2, 2s2, 2p6. Here in neon there is a in neon 2p6. In neon, in outermost shell there is a fully filled electron. There is a fully filled electron, and also neon can obey the octet rule. In neon electronic configuration, in outermost shell there is a 8 member of electrons. It obey the octet rule. Like this, children, write your configuration, learn configuration, and practice also electronic configuration. It is easy to write so many questions, chemical bond questions, electronic configuration questions, like that, equation, chemical equation, and also all of these chapters are linked with electronic configuration, number of electrons, and also classification of elements, periodical table. These are all important topics for your examination. Okay, children, let us give some. Okay, I can recall the structure of atom. We learn about first what is meant by atom, spectrum, electromagnetic wave, electromagnetic spectrum, and shape of s orbitals, shape of p and d orbitals, and also electronic configuration. All of these important topics are covered by us. Okay, then you have more chances to asking question in this chapter. This is very important chapter, and also this chapter is basic for to understanding the remaining chapter, that is classification of elements and chemical bonding. Especially chemical bond is understand by this chapter. That's why I am telling. I will telling first this chapter, then I will tell chemical bond chapter in our next session. Okay, Nana, we will take homework for you. Write down the homework on your notes. Draw the electromagnetic spectrum. Draw the electromagnetic spectrum. define wavelength, define frequency, relations, and E is equal to h mu relation, and practiced E is equal to h mu problems, and shape of s orbital and shape of p and d orbitals, and electronic configuration are practiced. Practice the electronic configuration, and also you can learn Aufbau principle, Pauli's exclusion principle, Hund principle. Okay, thank you for watching my video. Thank you children.